Imagine a stack of plates. You can only add or remove plates from the top. That's exactly how a stack works in programming. Now, imagine a train where you can add or remove passengers from both the front and the end. That's called a deck. Today, we'll learn what stack and deque are, how they work, where they are used in real applications, and we'll also write code examples step by step. What is a stack? A stack is a linear data structure that follows the rule LIFO, or last in, first out, which means the last item inserted is the first item removed. So what are the important operations in this stack? First one is push, which means add item to the stack. Second one is pop, which means remove the top item. Third one is peek. That means weave the top item. Is empty is used to check if the stack is empty. Think of a stack like a piling plates. You place new plates on the top and you are also removed from the top. Let's talk about how the stack works in step by step. As a first step, you push 10. And as the second step, you push 20, which means you add another 20. Push 30 means you add another 30 to the stack. So if you want to do another operation called pop, 30 is being removed from the stack. This is how the stack works. Notice that the most recently added elements gets removed first. That's why stack follows last in, first out. Now, let's talk about Java stack example. Here, this import is used to bring a built-in Java class into the program. Next, this Java util.stack is Java's ready mode stack class. These operations allow to use stack. Here, public class stack example is a class named. In Java, every program must be inside a class. So, what this line does is the main method. Java starts executing the program from here. It's like start the program from this point. And then create a stack object. This is the data structure type. Integer means this stack stores integers only. And variable name with stack and creates a new empty stack. So these operations, what happened here is when stack.push10, it means adds 10 to the top of the stack. Then the stack becomes 10. Again, stack.push20 means add 20 to the stack. Then stack becomes 10, 20. Then again push 30 means the stack becomes 10, 20, 30. 30 is now at the top. Stack.pop means remove the top element, which means stores it inside the variable removed. Since the stack follows last in, last out, 30 is removed. So the top element is now 20. So the stack becomes 10, 20. Here the peek operation, stack.peek means shows the top element. It does not remove the top element, it does only show it. So the top element is now 20. So the final output is from here S out stack is 10, 20, 30 and output removed is 30 and then the top element, which that means the peak operation, is 20. Next, let's talk about real-world uses of stack. First one is browser history. That means pressing back removes the latest page first. Next one is undo feature. That means latest action gets undone first. Third one is function calls. Programming languages use stacks to manage functions. Industrial example is in text editors like Microsoft Word. When you press Ctrl plus Z, the latest action is removed using a stack structure. So these are basically what is all stack is about. Now let's talk about what is a DEQ. DEQ stands for double-ended queue. That means a DEQ allows insertion and deletion from both ends. For real-life example, think of a train. Passengers can enter or leave from the front or the back. So the important operations in this DEQ is append. Append mean add to rear. Append left is add to the front. Pop, like as the stack, means removes from rear, and pop left means remove from the front. Now let's talk about a DEQ example step by step. First step is we add 10 to rear. This is the DEQ and this is the front and this is the rear or the end. We insert or remove first from this front and insert last or remove last from this side. So first we add 10 to rear. Second, we add 20 to rear. So that becomes 10, 20. Third, we add 5 to the front. And if you want to remove from the rear, let's think we remove 20. So from rear, 20 is removed. So unlike stack, DEQ is more flexible because elements can be inserted and deleted from the both sides. That is what's special about this DEQ. Now let's talk about a Java DEQ example. Here, imports Java built-in DEQ classes. It allows adding and removing items from the both ends. This is the class name. It means it creates a class named DEQ example. And this is the main method where the program starts running. So what this does is creates an empty DEQ that stores integers only. At first, it is empty. So now we add elements by DEQ.addLast 10. Then it adds 10 to the rear from the back because this is add last. So the DEQ becomes only 10. Then we add 20. Then the DEQ becomes 10, 20. Then we add 5. Then 5, 20, 10, 20. Because here we added from the last. That means 10, 20 from the back. Here we add 5 from the front of the DEQ. So if we print out the output, after all this insertion, it becomes 5, 10 and 20. So there say remove last. That means 20. So if we remove last, we remove 20, it becomes 5 and 10. And then they say remove first. That means 5. So after the removals, the output is 10. So another example, think of it like a line of people. People can enter from the front and also from the back, and people can leave also from the front and the back. That flexibility is how a deck works. So in real world uses, a deck is used for task scheduling. That means tasks can be added or removed from either sides. Then we use music, we listen to music daily. So in your playlist, you can select the next or the previous song as you wish. That means it can be managed efficiently. And also in web browsers, tabs and navigation systems sometimes uses decks like behavior. In industry, decks are used in task scheduling where processes may enter or leave from different ends depending on the priority. So if we talk about the differences or the comparison between the stack versus deck, stack has access only on one end, where deck has access from the both ends. Stack uses the LIFO rule, which means last in, first out. Deck is more flexible, where we can add or remove from the both ends. Insertion in the stack, we can only add from the top, but in the deck we can insert from the front and the rear. Also, the deletion is also, we can only in the deck we can only delete from the front and the rear, where in the stack we can delete only from the top. For an example, stack is undo button. We undo the last thing we did first. As for a deck, a playlist is example. And that's the basic of stack and deck. If this video helped you understand data structures more easily, don't forget to like, subscribe and share. NodeNotes for more beginner-friendly programming content. See you in the next video.